Okay, so we had some slight technical difficulties. And so what were we talking about? We were talking about Riemann sums, left sums in particular. And so when we were talking about left sums, let's look at the notation of what we could be dealing with. So we're taking the height of f of x naught and the height of f of x1 all the way out to this point where we're talking about f of x sub n minus 1. So if I was going to write this in sigma notation, that would be the sum k, which would equal 0 up to n minus 1 of f of x sub k multiplied by delta x. Okay. Now, how is this related to the integrals that we were talking about? What if we, look, if I took the limit as n tends towards infinity of the sum k, which equals 0 to n minus 1 of f of x sub k multiplied by delta x, this would actually equal the integral from a to b of f of x with respect to x. Okay? So what do I mean by the limit of this sum? The limit of the sum, okay, so this guy is discrete. It's adding up rectangles, basically. What happens when you make the rectangles infinitely thin? Okay, so this delta x right here, the delta x starts becoming smaller and smaller and smaller. The rectangles become infinitely close to each other. So instead of being a sum, we write it as an elongated s. Right? And the a and the b tell us where to begin and end the integral. And the delta x actually means, well, instead of being a delta x, a discrete x, it becomes a dx, which is a measure. Okay? It means integrate with respect to x. So you're integrating along the x-axis. So this is what is actually meant by an integral. So your sigma, instead of being discrete, becomes an elongated s. And your delta x, which was the measure that you were dealing with, the width, actually just becomes a dx. Okay? And so this one right here is a left sum. Let's have a look at what a right sum would be. So if we did a right sum, now let's take that same type of curve. Okay, but instead of taking left endpoints, I'm going to take right endpoints. So the height of my triangles is going to correspond with the right endpoint of rectangles, not triangles. Now, for your extra credit project, it doesn't matter if you choose right endpoints or left endpoints. Okay. So, we call this x naught, x1, x2, all the way out to x sub n minus 1 and x sub n. Okay. Now, the ordering of this. All right, so on the last problem, we started out at 0, and we went all the way up to n minus 1, okay? Now, at this one, notice we're not considering f of x 0, okay? This is actually starting f of x 1. So this approximation would be f of x 1 multiplied by delta x plus now f of x 2 multiplied by delta x, and this is going to go all the way out to this height right here, which is f of x sub n. That's where we're going to end it. Okay, and that would be now the sum k, which equals 1 all the way out to n of f of x sub k. Now multiplied by the delta x, which is the base of the rectangles. So the difference between the left sum and the right sum is that when you do the indices right here, this one begins to get k, which equals 1, because we're starting with this right endpoint, and it goes all the way out to k, which equals n. Whereas the left endpoints would start out at 0, f of x sub 0, and they would end up ending at f of x sub n minus 1.